So I think programmatically we've had a couple things that have impacted us a little bit. So after EFT1 and we had those failures early on in URT1, we had a very successful mission, but we came back and said, we need to go back to the drawing board and let's figure out how to do this better in the future. And there was a trade study that looked at 37 concepts that the team analyzed for the best ideas going forward. And we had a trade study concept that we started to design. And after that was figured out, we got new requirements from Orion for their structure and their base heat shield. So that made that a little challenging. We are in a constantly adapting program where we get new requirements that we have to adhere to. And those were pretty important requirements because we need the heat shield to be intact so that we can make sure that it's going to be safe to fly crew. So we made some modifications to our design. Some of it had to change, but we were able to work with our Orion partners to make sure that what we have is sufficient. Also, we have a launch date that we're trying to get ready for, and that requires, testing is pretty intense, require about 600 people to go out on the ship. It's not a small feat to plan that, so we have to plan those dates with the Navy, and we really they can't just change their schedule because NASA's hardware is not ready. So when we have a date that we've made with the ship, we plan for that, we hold that date as much as we can, and we have to be ready. We can't, so our schedule is pretty important that we're right on. And if we have schedule slips, then we make sure that they know immediately because it takes about 15 months to schedule one of their ships. We know that there's always the possibility of a launch scrub, and for the actual mission, which is different than integrated testing, the DoD is very flexible and they work with us on those scrub turnaround. We actually had one of those for EFT1. We had a scrub. They were at sea a day longer than they thought they were going to be to wait for the actual mission. So we do have flexibility to work with DoD on those types of things. Typically, pretty quickly if you don't come back earlier. If we have to come back early, that's considered an abort. If we come back early, that's considered an emergency, and so we don't use the Navy off the coast of California for that. We could maybe use them as best effort, but it's not a system where everything's loaded in the ship and you've got the whole team on board and we go out and we try to recover it. We call the boilerplate test article. We did a lot of incremental testing to lead up to our first underway recovery test. So we had a lot of information, but what we underestimated were the loads and the waves, what it would, in the well deck, what it would do to the capsule and to the lines attached to the capsule. And that's when we had some hardware failures, we broke some lines and attach points. So the use of a well deck, we did a trade study. We looked at 37 different options. They even looked at a submarine, bringing a submarine up. We've looked at commercial ship options. We looked at different things the DoD had to offer, a crane, and the well deck ship was the best for all of our needs. So it's not just about recovering a capsule. We need helicopters. We need medical to accommodate the crew. Our weather alternate is up to 1,200 nautical miles away, so we basically need to have everything that we have to use to affect the crew medically, and the team needs to really be on a floating city, basically. And so after looking at all the requirements we had from everyone from the crew office, health and medical, Orion, GSDO, it turned out that the LPD was the best option for recovery. When we get it back to San Diego, it's in the cradle. And so we have these big pieces of hardware called the CLTs, and they couple together and they hold onto the cradle, and they allow us to use a forklift to lift the cradle. And we basically forklift the cradle and the CLTs married together off. We do some processing. We put on a short stack lifting fixture, which is a ring that we install on the top that allows us to crane the CM onto a semi-truck in a recovery transportation fixture, and we put some instrumentation on it so that we make sure that the loads and the temperatures and that kind of stuff are okay, and then we transport it back across the country.